Go.
All right, so I'm going to give you guys each a packet, okay? And so my first question to you guys is, how many of you have heard of the distance formula before or ever used it? Awesome. Now, how many of you know why it works? Good. Okay, so that's going to be the point of today's lesson. We're going to be talking about distance on the coordinate plane. So let's take a look at the graph that you have in front of you. I want you to start by just plotting 2 points. Okay, the first point that you're going to plot is -1, -1. And you can keep your scale at 1. You won't need to change your scale. Okay, so -1, -1. Everyone double check, make sure you've got a point that looks like it's right about here. Good? Okay, now I want you to plot a second point. Let's do 2, 3. Good? Okay. And what I want you to do is I want you to just draw a line connecting those two. It doesn't have to be perfect, but just draw a line. Okay? And to reiterate, we're finding distance between these 2 points. Okay? Your first instinct is probably going to be to use the slope formula. But what does slope tell you? Just shout it out. How what?
Steep it is.
How steep. Does that tell you how long the line is?
No.
No. So even though it's very intuitive to use the slope formula when you've got 2 points, that's actually not going to be appropriate to tell you how long that line is. Okay? So let's use the distance formula. Does anyone remember what it is off the top of their head?
Square.
Yeah.
Okay, so we remember the square root. Let's try and figure it out. So we remember the square root.
D
I can
equals,
write
Okay.
right?
D
Oh, x2 minus
x equals
x1.
negative b plus. Wait.
Quadratic formula. So that's not how to do it.
Why?
x1 minus x2 squared
Okay?
plus y1 minus y2 squared.
x2, well, let's do the 2's first, just for the sake of argument. x2 minus x1 squared plus, and then parentheses again, y2 minus y1 squared. Okay, so everyone just write that in for your notes. Okay, and my goal for you today is that you no longer have to memorize it, but that you can actually figure it out. Okay, it'll last a lot longer that way. So let's take a look at method number 1. Method number 1 is the way you already know, which is to plug in the values. So let's look back at those 2 points you plotted. If you don't mind, either on the side or by the point, just write in those coordinate pairs. So you've got -1, -1. You've got 2, 3. So write them in somewhere. And what I want us to do is I want us to label them. So we've got an x and a y and an x and a y. Okay? How do we distinguish between these two x's?
X1 and x2.
X sub 1, x sub 2. Good. So just label them. Let's do this as x sub 1. This one x sub 2. Okay, so we'll do -1 as x sub 1, 2 as x sub 2. It doesn't matter, but let's all be consistent with each other. Okay? So conversely, what do we expect our y's to be?
Y1 and y2.
y1. Tell me the value of y1. Let's just make sure we're all on the same page.
Negative.
Good. Tell me the value of y2. Perfect. Okay. Now we can all sub in pretty easily, right? Let's do this on our own for about 10 seconds. When you're done, look up at me.
Do you want us to solve it?
Mm-hmm. Yep. Find the distance. Okay. And when you're done, look up at me. Good? Good? You guys need help with anything?
No, I'm just really bad. Hold up.
Where are you right now?
The seconds, I messed up the numbers.
Oh, is it the subtracting the negatives?
Yeah.
When you
Oh,
subtract
no.
a negative, what is that?
Don't they both change? Wait, but it would be like 2 plus 1, right? These are both
Yes,
negatives.
because 2 minus -1
Yeah.
is the same thing as 2 plus 1.
So you'd have like 3 squared plus 4 squared.
Perfect.
Okay.
Good. Okay, so what do we get as our answer?
5.
Good. So you should get the square root of 25 when you simplify that. Does that look familiar, Courtney?
Yeah.
Good. And then the square root of 25 is just 5. And you know it could be negative, but there's no sense in a negative number being distant, so we can just throw that out entirely. Okay, so far so good? All right, now I'm going to show you why that works. This is where things get cool. Okay. What I want you to do is I want you to think of this as the shortest distance between 2 points, okay? And that's always going to wind up being the hypotenuse of a right triangle. All right, so let's draw in a triangle. What I want you to do is I want you to follow this line here that's parallel to the x-axis, and I want you to follow this line here that's parallel to the y-axis, and I want you to make a perfectly right triangle. Okay. So far so good? Okay, I want you to tell me, how long is this base here?
3.
3 units long, right? So I'm going to label that 3.
What quadrant are we in? Second?
Well, we're kind of actually straddling 3 quadrants.
I didn't know. I mean, like, which?
Oh, you could actually use either one. It's not going to
Okay.
matter. I'm using the bottom one, but you would get the same exact answer if you use the top quadrant. Okay? So far so good? And now let's look at the height. The height of this triangle would be what? 4. Okay? So you've got 3 and 4. Does anyone see in the quadratic formula those numbers? Excuse me, not the
Yeah.
quadratic formula, the distance formula.
Yeah.
Yeah.
You guys see those? Not an accident. Okay?
Wait, where?
This 3 here,
Whoa.
this 3 here, watch this,
That's weird.
is the change in your x's. If you take x2, which is 2, and subtract x1, which is -1, you're going to get 3. So this is like the horizontal change. Does everyone see that? And horizontal is just like your x-axis. So you can remember that that one's going to be your change in x's. So you can call this delta x if you want. That's your change in x's.
X2 minus X1?
Uh-huh. And so why do you think we're subtracting?
Because you find the difference.
Finding the difference. Very good. Right? It wouldn't make any sense to add those numbers. That's why we're subtracting here. Okay? Now, what do you think this thing is going to be then? If it's the vertical delta y, the change in the y values. So if you look at your y2 and your y1, 3 take away -1 gets you the 4 that you counted. Cool? So that's your delta y. Okay? Now here's the big magic rule. You can only count across or up. You can never count the diagonal. So it's very tempting to just say, okay, 1, 2, 3, 4, it looks like about 4 units, or approximately 4. We can never, ever, ever count the diagonal. So what's super easy is if we just draw in that right triangle, count the sides, and then use the Pythagorean theorem. And really, the distance formula is just the Pythagorean theorem in disguise. Okay? So now let's use the Pythagorean theorem. Let's go to method number 2. Okay? What is the Pythagorean theorem?
A squared equals B squared.
You guys are awesome. A squared plus B squared equals C squared. Okay? So A and B are our legs, and C is our what?
Hypotenuse.
Hypotenuse. Awesome. So we're going to solve for C because we don't know it yet. So what's A equal to?
Are we using the 3?
Mm-hmm.
Okay, so 9.
3 squared. So careful. A is 3, and then you would square A to get 9. Yep. So 3 squared plus,
4 squared.
Squared.
okay, equals C squared. Okay. So 3 squared, let's evaluate it. 9 plus
16.
equals C squared. Now this is looking very familiar, right? You can see
Yes.
all of these steps above.
Mhm.
All right. So now let's simplify 9 and 16.
25.
25 equals C squared. So how do we undo that operation?
Square root.
Square root it. Okay, and now you can see where that giant square root came from. It was undoing that C. Pretty cool, right?
Yeah.
Okay. So now I'm going to give you guys a chance here.
Alright.
Flip over to the next page. You should see 4 practice problems. Okay? I'm not set on us doing all 4. We'll see what time allots. Okay? But I'd like you to at least try one of the first 3. Okay? And also try the last one. Okay? You can pick any method you want. So whichever you find easier, go for it. Okay?